So, in the end, will the sun be to blame for destroying our planet? Or how about a huge meteorite? Or some kind of disease? Probably not. It seems that life will disappear for a very unexpected reason. Humans, animals, insects, fish, and most microbes will be wiped off the face of the Earth because of oxygen, or more precisely, because of its absence. Recent research has shown that the number of freshwater reservoirs with very low or no oxygen levels in coastal areas is increasing worldwide. Over the past 65 years, 4 times more oxygen-deficient waters have appeared in the world's oceans. What does it all mean? It's likely that life on Earth will vanish much sooner than the sun's energies dries up all the oceans. The end is likely to come in a little more than 1 billion years. But this doesn't mean that the planet will disappear too. The period when Earth is filled with oxygen will make up just about 20 to 30% of the total lifespan of the planet. So we're just temporary guests here. Just think how long that is, 1 billion years. The first Homo sapiens appeared only about 300,000 years ago. That is, the entire history of humanity occupies less than 500,000 years. So relax. 1 billion years won't pass very fast. By that time, humans won't be on Earth anymore. We might master space travel and find a new planet in the vast depths of space. But why can we lose air? As the sun heats up, the planet gets warmer and warmer, and this heat breaks down carbon dioxide, the gas which is necessary for all plants to photosynthesize. Without carbon dioxide, they can't produce oxygen. With a drop in carbon dioxide levels, the methane content will increase, and this gas is quite harmful to us. Now, this all sounds logical, but this is a secondary reason for the lack of oxygen. The real problem is something else entirely. As the sun becomes brighter, it will begin to heat rocks on Earth, such as granite and basalt. These rocks will start to break down faster. When they collapse, they take carbon dioxide from the air, which warms our planet. If there's less carbon dioxide in the air, Earth should become colder. But there's a problem. The sun will shine more, and its heat will outweigh this cooling effect. So even if rocks take away carbon dioxide, the sun will blaze so much that Earth will still become extremely hot. Next, when the sun shines more intensely, it, along with other natural factors, contributes to the breakdown of granite and basalt. These rocks mix with carbon dioxide and water to make carbonates, which go deep into the Earth. This takes carbon dioxide out of the air, which means plants can't make as much oxygen because they need carbon dioxide to do that. Besides, volcanoes release gases, which also reduce the amount of oxygen in the air. So the sun, by destroying rocks, affects what happens inside Earth and controls how much oxygen there will be in the air. In about 1 billion years, the sun will become so bright that no rocks will be able to save Earth from its heat, and the escaping gases will halt photosynthesis and oxygen production. And then, our planet will return to the state it was in about 2.4 billion years ago, to the time when the Great Oxidation Event began. And this event was much more important than, say, the first Olympic Games or the appearance of humans on the planet. Billions of years ago, there was almost no oxygen on Earth. Instead, there was a soup of gases, such as nitrogen, ammonia, methane, carbon dioxide, and others. Yes, we have these gases in the atmosphere today, but there used to be a lot more of them in the past. It was difficult for any form of life to originate in such conditions. But after some struggle, it succeeded. At first, Earth was inhabited by the simplest bacteria, including cyanobacteria. They learned how to make oxygen using sunlight, water, and carbon dioxide. These bacteria worked for millions and billions of years and made so much oxygen that it began to accumulate in the air. This was what we now call the Great Oxidation Event. It was like a great celebration of life, because with oxygen, new living beings could appear. But by the way, cyanobacteria didn't learn photosynthesis because they were like, oh, let's make oxygen, it's so cool. No, oxygen was just a byproduct. Cyanobacteria wanted only one thing, to get as much energy as possible. And for this, they learned photosynthesis. It helped them store energy using sunlight. They used special pigments to absorb light, and the result of this process was the release of oxygen. This had been going on for hundreds of millions of years, and then, at some point, they made too much oxygen. This oxygen started to spoil other gases that had been there before. For example, it ate a lot of methane. Because of this, Earth cooled down a bit, and the Ice Age began. But that's another story. In short, in a billion years, we risk going back to that difficult time. But let's hope that we'll manage to move to another planet on our spaceships or come up with some other solution. And what'll happen to our home planet next? Will new life be able to originate there without so much oxygen? Well, it's possible, but it'll be much more difficult. This will require another source of energy besides the sun. It can be, for example, hydrothermal vents. And by the way, there are ecosystems on Earth that use this type of energy. You can find one of them in the Mobile Cave in Romania. Imagine a place where there's little oxygen. It's dark. The sun's rays don't reach there. Over millions of years of evolution, a unique and slightly creepy life has developed in this cave. It was first discovered in 1986, and scientists are still exploring this place. The entrance to the cave is just a small hole in the ground. A narrow tunnel goes deep underground. Inside the cave, the air is filled with hydrogen sulfide and carbon dioxide, and there's half as much oxygen there as on the surface. A human can't stay there without a special mask. But for local forms of life, this is home, and they feel great there. There are several dozen species living in the cave, and many of them aren't found anywhere else on Earth. Here you can see strange little monsters, white snails, white spiders, centipedes with long whiskers, transparent shrimp, and even unknown species of leeches. Since there's no light in the cave, all these creatures don't need eyes. They're blind, but they have long sensitive antennae and paws that allows them to navigate in the space. They also have no colored pigment, so all these bugs and spiders are either white or transparent. But if there's so little oxygen there, and nobody does photosynthesis, then how does all this life survive? It's all thanks to the unique bacteria autotrophs. They absorb carbon dioxide and produce nutrients. These bacteria are food for other organisms, and those, in turn, become food for larger creatures. So a whole food chain has been built in the cave, which provides all the inhabitants with food. Evolution has created a unique ecosystem that exists separately from the rest of the world. It's like a small universe that has developed according to its own rules. However, this universe is not expanding, because all living beings here can't live away from hydrothermal vents and autotrophs. Otherwise, where would they get their energy from? But let's imagine that the sun cools down, almost all the oxygen disappears, and the entire planet gets covered with hydrothermal vents. It's dark, and the air is filled with methane, CO2, and other substances. And somehow, life begins. Even people appear at one point. What would they look like? Pale, thin, and blind creatures with very long arms that help them navigate in space. They have pets, large centipedes or cockroaches that move silently on the ground. People are also quiet because they don't have lungs filled with air to scream. There's silence in the world. People communicate through touch. No one travels. Everyone lives separately next to their hydrothermal source. The whole world has turned into a horror movie in a billion years.
Put on your woolen hats, find the warmest mittens, and go buy the thickest blankets. The next ice age might be just around the corner. And the trigger is much more shocking than anyone might have expected. What's even worse? We have no control over our bitterly cold future. Earth's climate has been on a wild ride for millions of years. It's been warming up, freezing over into ice ages, then heating up again to the more normal temperatures we know today. These cycles, called quaternary ice ages, are part of a much longer pattern of global freezing and thawing. For a long time, scientists thought Earth's orbit around the Sun had something to do with triggering ice ages, but figuring out exactly how was tricky. Well, new research has finally connected the dots. It shows how tiny changes in Earth's tilt, wobble, and orbit mess with the growth and melting of huge ice sheets. This is a pretty big deal because it helps scientists understand not just what happened in the past, but also what might happen to our climate in the future. Even small shifts in how Earth moves through space can have huge effects over thousands of years. These changes control how much sunlight different parts of the planet get, which affects how ice sheets grow and shrink. Earth doesn't orbit the Sun in a perfect circle. It actually follows a slightly oval-shaped path. This phenomenon is called orbital eccentricity. Since the Sun isn't sitting right in the center of this oval, Earth's distance from it changes throughout the year. Plus, the oval itself slowly shifts position in space over time, which is called orbital precession. On top of that, Earth's tilt, aka obliquity, also changes slightly as our planet moves around the Sun. Scientists have known for a while that these orbital quirks impact our planet's climate, causing cycles of warming and cooling. As different parts of Earth's orbit shift, they change how sunlight is distributed across the planet, influencing seasons and ice ages. These Milankovitch cycles happen roughly every 20,000, 40,000, 100,000, and even 400,000 years. The difficult part is to figure out how each of these orbital changes affects climate shifts. Earth's climate is a complicated system, with tons of factors influencing it at the same time. Modeling all these processes is no easy task. It needs huge computing power and a deep understanding of each factor's role in shaping our planet's past and future climate. There are two cycles that are super close to each other in timing. Precession, which happens every 21,000 years, and the second harmonic of obliquity that happens at 20,500 years. But even though they're so close, no one has been able to directly connect either of these cycles to the end of an ice age. On top of that, for the past 800,000 years, ice ages have ended every 100,000 years, and scientists still haven't figured out what causes this pattern. To get to the bottom of it, researchers turned to the deep sea. They studied changes in oxygen isotope ratios found in the tiny, fossilized shells of marine creatures. These tiny creatures live in the ocean, and their exoskeletons preserve clues about past climate, specifically changes in ice sheets. This allowed the researchers to track the beginning and end of ice ages over the past 800,000 years. By comparing the changes in the ice sheets with Earth's orbital changes, they found an incredible pattern. The key moments when Earth moved between ice ages and warmer periods were perfectly lined up with specific relationships between precession and obliquity. It turns out that the end of an ice age, called deglaciation, is closely linked to the way precession and obliquity align. But it's obliquity alone that seems to trigger the start of an ice age. This discovery is the key to understanding the 100,000-year cycle of ice ages. The researchers say it was always there, just waiting to be noticed. Before the discovery, people thought the timing of ice ages was more random. But this new study shows there's a clear, predictable pattern. This means we might actually be able to predict when ice ages will happen in the future. Right now, Earth's tilt is slowly decreasing, and in about 11,000 years, it'll hit its lowest point. Based on the team's calculation, the next ice age is expected to begin before then. At the same time, according to the latest reports, humans have already started pushing Earth's climate off its natural path by releasing greenhouse gases. Another thing scientists are warning about is a massive shift that's happening in the Atlantic Ocean, and it could drastically change the world's climate. The Atlantic Meridional Overturning Circulation is a system of ocean currents that moves warm and cold water around the planet. And right now, it is showing signs of weakening. What will happen if it collapses? Freezing temperatures in Europe, extreme weather across the world, shifting monsoons, and even an Amazon rainforest drying up. And the scariest part? Some researchers say there's a 95% chance this could happen before the end of the century. Think of the AMOC like a giant conveyor belt in the ocean. Warm, salty water from the tropics flows north towards Europe and North America. When it reaches colder areas, it cools down, becomes heavier, and sinks to the bottom of the ocean. This deep, cold water then moves southward, while fresh, warm water from the equator keeps flowing north to replace it. This system helps regulate global temperatures, keeps Europe's winters mild, and prevents the US East Coast from flooding. It also controls monsoon patterns that bring seasonal rain to parts of Africa, South America, and Asia. Without it, the world's climate would look completely different. Right now, melting ice from Greenland and Antarctica, along with increased rainfall and river runoff, is dumping too much fresh water into the North Atlantic. Since fresh water is lighter than seawater, it disrupts the sinking process that keeps the AMOC moving. If too much fresh water builds up, it will mess up the entire system. And once it collapses, there will be no reversing it, even if the climate later cools down. Scientists have seen two big warning signs. First of all, the warming of the ocean off the US East Coast, which suggests the AMOC is already slowing down. Plus, there's a cold blob of water south of Greenland. It might be a sign of the weakening of the ocean current, and that's exactly what happens before the system fails. What would happen if the AMOC fully shut down? Europe would enter an ice age. The AMOC plays an important role in keeping Europe's winters relatively mild by bringing warm water north. If this process stopped, Europe would be plunged into deep winter. London's climate would drop by 18 degrees Fahrenheit, making it feel like northern Canada. Stockholm could get up to 54 degrees Fahrenheit colder, turning it into Siberia-like conditions. And snow and ice would cover much of northern Europe year-round. Next, monsoons would shift, leading to severe droughts. The AMOC helps regulate tropical rainfall, especially in Africa, South America, and Asia. If it collapsed, West Africa's monsoons would shift or disappear, leading to devastating droughts and a massive food crisis. The Amazon rainforest could dry up, transforming into a savanna or grassland. In India and Southeast Asia, monsoon rains would disappear, and millions of people rely on them for agriculture. The US East Coast could see catastrophic flooding. With the AMOC weakening, water is already piling up along the US East Coast, triggering higher sea levels and stronger hurricanes. If the system shut down, sea levels would rise by up to 3.2 feet, which would make the coastal cities more vulnerable to flooding. Finally, hurricanes and extreme storms could become even more powerful because of warmer waters along the coast. Now, how close are we to disaster? For thousands of years, the AMOC has remained stable, but recent studies suggest it's weaker now than at any point in the past 1,600 years. Ocean temperatures are hitting record highs, and many researchers believe we are dangerously close to the tipping point. A study published in Nature claims that if greenhouse gas emissions continue at their current pace, there's a 95% chance that the AMOC will collapse before 2100. Right now, 4 tiny, Earth-like planets are chilling around one of the closest star systems to us. We're talking second closest. These little rocky worlds are each about 20 to 30% the mass of Earth. So not quite Earth 2.0, but still pretty solid. Will one of them become our new home one day? Well, all of them are pretty close, so future humans might actually visit them someday. Not like next year or anything, but we could potentially send missions there. Don't expect any extraterrestrial neighbors, though. Those planets probably aren't home to life, or at least not anything we'd recognize. Let's take a look at them. The planets are called Bernard B, C, D, and E. How creative, huh? The innermost has a mass of 26% of Earth. The second one is a bit bigger, with a mass of 30% of Earth. The third one has 4% more mass than the previous. And the outermost is... no, it's not the biggest. Actually, it's just a baby, with a mass of 19% of Earth. All the planets are likely rocky, like the inner planets of our solar system. They orbit their star very closely. That's why they only need a few days, under a week, to make a full circle. Now, what about that star these little guys are circling? It's called Barnard's star. Astronomers have always had a hunch there might be at least one planet orbiting it. First off, this star is super close, in cosmic terms of course. Only the Alpha Centauri trio is closer to us. Barnard's star is just under 6 light-years away, which is basically next door. At the same time, it's not like our Sun. Barnard's star is a red dwarf, the most common kind of star out there. It's got only about 1/6 the mass of the Sun. But red dwarfs are a goldmine for learning about planets outside our solar system. And studying Barnard's star can help scientists figure out what planets around single stars, like our Sun or this red dwarf, are like. Or what kind of environments red dwarf planets might have. And most importantly, we might finally find the answer to this super important question. Could any of these places actually support life? For the longest time, scientists thought there might be a big Jupiter-like gas giant hanging out near Barnard's star. All because the star has a little wobble. It looks as if it shifts towards and away from Earth over time, so something might be tugging on it. Interestingly, it wasn't a giant planet doing the pulling. According to a study from March 2025, it's actually 4 smaller rocky planets, each about 4 times the mass of Mercury. One day, they ganged up and started tugging on the star together. These planets are incredibly close to their star, so close that they can whip around it in just a few days. Sadly, because of that, they might be way too hot for anything like life. Besides, since these 4 seem to explain all the star's movement, the researchers think there's probably nothing else orbiting the habitable zone. So, there's no Earth 2.0 orbiting around Barnard's star. Still, it's an awesome find, especially since this star is basically our cosmic neighbor. Plus, the system might not stay off limits forever. With nuclear fusion engines or light sails, futuristic propulsion systems that could make the trip way faster. We might probably go there one day. And then we'll finally figure out if these worlds are really lifeless and maybe even colonize them. Now, let's see how scientists found the star's hidden planets. Normally, astronomers spot exoplanets when they catch them crossing in front of their stars and blocking some light. But Barnard's star is tricky because, in our view, it's like we're looking from above the system, so its planets don't block the light in the usual way. That's why they call it the Great White Whale of planet hunting. To get around this, researchers used a super sensitive instrument called Maroon X attached to the Gemini North telescope on Hawaii's Mauna Kea volcano. Over 112 nights, spread out across 3 years, the telescope picked up tiny changes in the star's movement. These shifts let scientists figure out how many planets must be tugging on the star, as well as estimate their sizes. At first, they found 3 planets. But then they used another device, deliciously called Espresso, and located at the Very Large Telescope in Chile. And only after a shot of this espresso did they find a 4th planet. By combining the data from both instruments, they were able to more or less confidently say their findings were solid, not just random glitches in the data. Even though red dwarfs like Barnard's star are the most common type of star in the universe, most are way too far for us to see planets around them easily. These new findings suggest that small rocky planets could be pretty common around these stars, and that's huge for future discoveries. Now, finding new exoplanets is cool and all, but it might be even more exciting to dwell on their birth and evolution. And a recent study has made the sweetest discovery ever. Newly born exoplanets might actually look like Smarties, that popular British candy, rather than spheres. We've always kinda assumed that baby planets are born ball-shaped, but they might be oblate spheroids instead. A team of scientists from the University of Central Lancashire in England used computer simulations to build a model of the formation of planets in dense gas disks surrounding young stars. After that, they compared these models with actual observations and noticed that the young planets took pretty unusual shapes. The thing is that even though almost 6,000 exoplanets have been discovered so far, astronomers still don't have a clear understanding of the sequence of events marking their birth and early evolution. But this new research might finally shed light on this process. So, the astronomers examined the formation mechanisms of gas giant planets like Jupiter and came to the conclusion that planets built up from their centers. After that, the researchers focused on the initial shapes of such planets. They were also interested in how they could encourage the growth of these planetary seeds. How could they turn into such massive planets, some of them bigger than our solar system's largest giants? According to the standard theory of the formation of planets, such growth happens gradually and smoothly. First, dust particles start to stick together, turning into larger and larger objects. This process lasts for a very long time and is known as core accretion. It's the model of planet formation scientists favor. There's another theory, according to which planets' birth might happen over shorter periods of time. This data involves a protoplanetary disk, a disk of gas which makes up 99% of its mass, and dust, around 1%. This disk orbits a newly formed star, and hypothetically, planets might form from this cloud. Protoplanetary disks are likely to be common byproducts of star formation. They might range in mass from 0.001 to 0.3 solar masses. Inside such disks, matter slowly moves inward, and dust particles grow bigger, to the size of pebbles. At one point, after 2 to 3 million years, a giant rotating protoplanetary disk breaks into pieces, and that's how baby planets are born. This theory is known as the disk instability model. As for the model built by the team, it seems to support this second, less favored theory: rapid planet formation through disk instability. All because this theory explains how large planets can form relatively quickly at pretty large distances from their host stars. As for the weird flattened shape of these newly formed planets, it might be due to the material falling onto them. Most likely, it goes mainly to the poles of new planets. One of the main conclusions of the research is that the appearance of young exoplanets, as we see them from Earth, may vary depending on how they're angled. If Earth is directed face-on to an exoplanet, it will seem that the latter has a traditional spherical shape. But if seen on edge, a baby exoplanet will look like a real smarty. The team is going to continue to investigate the formation of planets with the help of an improved computer model. They believe they can find out the role the environment around a young planet plays in affecting its shape and formation.
For decades now, scientists have been discovering new planets outside our solar system. By 2023, we've found more than 5,000 of them, and many of these exoplanets could potentially even have life. Now, if you're ready for a wild ride through space, let's find out what potentially habitable planets we've discovered in the last few years. LP890-9b and LP890-9c. Buckle up because we're heading to LP890-9, a red dwarf star located a whopping 105 light-years away from Earth. This star is quite cool compared to our Sun, in terms of temperature, of course. It has a temperature of about 4,700 degrees Fahrenheit. Now, this little guy may be small, but is packed with surprises. For example, 2 exoplanets orbiting around it. Moreover, both of these planets are likely terrestrial, meaning they are rocky, just like Earth. First up, we have LP90-9b, which was discovered in 2022 using the TESS telescope and later confirmed by the Speculoos telescope. This planet is a super-Earth, weighing in at about 13 times the mass of our own planet. It's also slightly bigger than Earth, with a radius about 1.3 times larger. And if you thought Mercury's orbit around the Sun was quick, just wait until you hear about LP890-9b. It takes about 3 days to complete one lap around its star. Imagine falling asleep in freezing winter and waking up in hot summer. But the real showstopper here is LP890-9c. This one was discovered by the Speculoos telescope. It's a bit further out from the star and takes a leisurely 2.5 times longer to orbit than LP 890-9b. It's also a bit larger than Earth. But its real claim to fame is its location within the habitable zone of its star. That means it could potentially have liquid water on its surface and a climate suitable for life. Now this planet becomes a prime candidate for studying its atmosphere using the James Webb Space Telescope. But hold on. It's not all sunshine and rainbows for LP 890-9c. It's also really close to its star, meaning it's full of radiation that could potentially make it less habitable. And to top it off, it's tidally locked, just like our moon. That means one side of the planet is always facing the star and is incredibly hot, while the other is always in the dark and really cold. Scientific models suggest that this planet could be more like Venus in terms of its atmosphere and climate. And Venus isn't known for being human-friendly. But despite these challenges, LP 890-9c is still a fascinating exoplanet worth studying further. Who knows what secrets it may hold? Let's move on to the next candidates. GJ1002b and GJ1002c. An international team of scientists, led by researchers at the Instituto de Astrofísica de Canarias, has found two Earth-like planets just 16 light-years away from our solar system. They both orbit a red dwarf star called GJ1002. Our Sun is a yellow dwarf, which means that GJ1002 is much cooler and fainter than our own Sun. But that's okay. Both planets are very close to its star, so it shouldn't be too cold or dark on them. These planets, called GJ1002b and GJ1002c, are both in the habitability zone of their star, meaning they could potentially support life. Also, both of them have masses similar to that of Earth. GJ1002b is the inner planet and takes about 10 days to orbit its star, while GJ1002c takes a little over 21 days. These planets are great candidates for studying their atmospheres and could even be targets for future missions to search for signs of life. The most important thing is that these two planets could potentially support life, and that's pretty cool. Plus, the fact that they're located so close to us means that we might be able to visit them someday. Well, maybe not us personally, but And maybe one day, we'll even find some extraterrestrial life on one of these planets. Now that would be out of this world. But moving on to the next one. Kepler 1649c. Kepler 1649c, also known as the Lost Exoplanet, was rediscovered in 2022 by scientists using data from NASA's Kepler spacecraft. This exoplanet is located about 300 light-years away from Earth and orbits a small, cool star called Kepler 1649. It's about the same size as Earth, and just like the previous ones, it's located in the habitable zone of its star. Initially, the data about this planet was discarded. A special computer program called RoboVetter, written to automatically sift through the volumes of Kepler data, labeled this candidate as a false positive. In other words, the program thought it was just some kind of an error or interference. Fortunately, the researchers double-checked such things, and when rechecking the data, they managed to rescue poor Kepler 1649c. Now we know that this is a terrestrial planet just like Earth, and if it really does contain water, there could even be life there. But don't pack your bags just yet. There are still many unknowns about Kepler 1649c. For example, we don't know what its atmosphere is like or what kind of surface it has. It's also possible that the planet is tidally locked, just like LP 890-9c. That would be, unpleasant. That's why Kepler 1649c is definitely worth further study. Maybe it turns out to be a perfect place for us to set up a vacation home in the future. Just make sure to bring plenty of sunscreen since the planet is pretty close to its star and things could get pretty toasty. Kepler 1638b. This exoplanet is located about 5,000 light-years from Earth in the constellation Cygnus. It's also located in the habitable zone of its star. It was discovered in 2020 by the Kepler spacecraft through the process called transiting. They basically take a bunch of photos of the star at different times. After that, the programs analyze these photos and look for small spots and dots on them. These tiny dips in brightness may mean that a planet was passing by the star. Kepler 1638b is a bit of an oddball compared to most exoplanets we've found so far. It's about 4 times the mass of Earth and has a radius about 2 times that of Earth, making it a super-Earth exoplanet. Its orbital period is about 260 days, which is quite close to our Earth, and that's great! Finally, at least somewhere, winter and summer will flow normally. Kepler 1638b could have some liquid water there. That's why it's also a good candidate for further study, to see if it could potentially support life. Let's hope that we'll find out more about this planet in the future. And finally, the last one. Kepler 438b. Kepler 438b is an exoplanet located approximately 640 light-years away from Earth in the constellation Lyra. It was discovered in 2015 by the Kepler Space Telescope. One of the most interesting things about Kepler 438b is its size and location. It's about the same size as Earth and also orbits within the habitable zone of its star. But there are a few catches. For one, Kepler 438b orbits around a red dwarf star, which are known for their high levels of solar radiation and flare-ups. This could make the surface of the planet too hostile for life as we know it. In addition, Kepler 438b has a much shorter year, only around 35 Earth days long. This could lead to extreme temperature fluctuations on the planet's surface, but maybe it's home to some hardy extraterrestrial life forms that have adapted to its unique conditions. Or maybe not. Either way, it's definitely worth keeping an eye on. This is a small list of exoplanets that we've discovered in recent years. Now, with the use of new technologies, we'll be able to find new exoplanets much more often. Let's hope that at least a few of them will really be inhabited.
The only life that we are certain about so far in the entire universe is on planet Earth. Whether that life is intelligent is, let's say, arguable. But anyway, it's not surprising that we're tirelessly searching for life on other planets. So far, they've discovered more than 4,000 of them. But what's even cooler, NASA has compiled a new list of 24 planets that aren't just Earth-like, they're better. The conditions on them are so good that they're more comfortable than on our planet. So let's examine some of them. KOI 5715.01. Let's be coy, shall we? This wonderful planet is in the constellation Cygnus. And why is it so wonderful? Well, our sun is a yellow dwarf. And sorry, sun, even though you're not bad at supporting life, there are some stars that can do it better. Nothing personal. The planet KOI 5715.01 orbits near an orange dwarf. Orange dwarfs are stars slightly smaller than our sun and have a little lower luminosity. Did you like the alliteration there? Anyway, don't worry, it doesn't mean we're going to live in complete darkness. In fact, if the planet is found closer to the sun and it has a thicker atmosphere, it may even be lighter and more colorful than on Earth. Now, our sun has a very short lifespan. Right now, it has 7 to 8 billion years left to live, a little longer than Earth's age. But orange dwarfs can live from 45 to 70 billion years. This is great not only because we'll be able to hang out on this planet longer, but also because the planets around these stars have more time to form life. Now, ideally, we would need to find a planet next to an orange dwarf that is about 7 billion years old. It's very likely there will be at least some organisms there. KOI 5715.01 is about 5.5 billion years old. Yeah, it may not seem mature enough, but that's okay, neither do I. Our Earth is a billion years younger, and that didn't stop us. The planet is quite close to its star and is in a habitable zone. 1 year there lasts 190 days. Imagine going to elementary school and already getting a driver's license. It's almost 2 times larger than the Earth. The average temperature there is 52 degrees Fahrenheit, which is slightly less than ours, 57. But it mostly feels warmer there because strong gravity helps it hold on to heat in the atmosphere longer. It's a little too far away though, like 3,000 light-years from Earth, which is about 18 quadrillion miles. Yep, better bring a really big lunch with you. KOI 3010.01. This planet is found next to the star KOI 2010. This planet sounds like a very pleasant world. The average temperature on this planet is 67 degrees, so a little warmer than ours. But that's a good thing. Scientists believe that on a perfect planet, the temperature should be just about 10 degrees hotter than on Earth. The more heat there is on the planet, the more comfortable it is to live there. Also, the higher chances of developing life. The radius of this planet is nearly 1.5 times larger than Earth. There's some atmosphere, although we're not yet sure about its composition, but it's probably like the Earth's. Scientists think that we'll find an ocean there, and it can cover up to 60% of the surface, which is also cool. In a perfect world, water and land should be distributed more evenly than on our planet. A little more land means a little more territory and resources, right? But listen, this planet is actually very similar to the Earth. The semblance is so striking that scientists believe we have an 84% chance to find life there. Of course, not necessarily an intelligent life, but at least some animals. Wouldn't that be cool? Now, what do you think they could look like? Very Earth-like planet, but with stronger gravity. Well, if someone lives there, they're probably big but have a small height and strong little legs. Sounds adorable and scary. But we won't be able to find out the truth anytime soon. So far, for us, these planets are microscopic dots in space. We only have some dry, boring data about them and don't even know what they look like. We'll have to wait until we can find a way to get closer to these planets. Kepler 186f. This is also one of the best candidates for having life. This rather cute planet was nicknamed the Earth's cousin because it does have a strong resemblance. Anyway, these two planets are like sisters, not twins. Kepler 186f rotates near a red dwarf. Red dwarfs are stars even dimmer and smaller than orange dwarfs. Yeah, they'll also live for a very, very long time, but their luminosity is also quite low. However, Kepler 186f is closer to its star than we're to our Sun, so it shouldn't be too dark there. Well, at least not night-like dark. The sky on this planet is sure to be an unusual shade of red, like sunsets on Earth. What do you think? Would you like to live on a planet with an eternal sunset? The size of this planet is about the same as Earth. Not bad, not perfect. Why so? Because the coolest planets are those that are bigger than Earth and have stronger gravity. Now you'll probably say, but wouldn't it be harder to walk there and even harder to get out of bed on Monday? Of course. But on the other hand, this planet will pull the atmosphere better. The atmosphere will be thicker and denser. This means more protection from the scary space stuff, more oxygen, and more heat. Not to mention the fact that the bigger planets have more space to settle. Awesome, right? But of course, the Earth's size is also an excellent choice. Another cool fact is that the tilt of Kepler 186f is about the same as ours. It means that there should be stable seasons and a normal day-night cycle. Do you know how important the tilt of the planet is? Let's look at Mars. Mars is also, in fact, found in the habitable zone of our Sun, but its tilt is very unstable, and as a result, the entire ocean that could have been on it once now completely dried up. Today, it's just a red desert, and there's no life there. At least not as far as we know, but you see how important these tiny details are? This planet is also quite far away from us, 490 light-years. That's about 3 quadrillion miles. So yeah, we're just going to keep waiting for intergalactic travel. Kepler 62e and 62f. These planets were called the most Earth-like before we discovered Kepler 186f. They're very comparable to our home. Kepler 62e is about 1.5 times larger than Earth, and Kepler 62f is just slightly smaller than that. They're located in the constellation Lyra, which is about 1,200 light-years away from us. They both also orbit a red dwarf. 1 year on Kepler 62e lasts about 122 days, even less than on that first planet we talked about. Scientists believe that both 62e and 62f are sort of water worlds, warm places mostly, or even completely covered with water. If there is land there, it's probably just some islands. A world consisting entirely of islands. A fantasy dream for some, think Hawaii, and a nightmare for others, think Megalodon. But if you're a fan of ancient marine animals, just imagine how gigantic they could be there. Still, there are many things we don't know about this planet. Does it have a surface? What about its composition, density? One day, maybe we'll be able to answer these questions. And so, that's it for the super-Earths. Of course, the original list is much longer, and you can go check it out on the internet. Now, the best thing about all this is that these are planets that are better than the Earth. But we also know thousands of other exoplanets that are just close enough to ours. And the odds are, a few of them have at least some form of life. But they're very, very far away, so we have no way to check it out right now. Perhaps, down the road, we'll find some cool creatures on many of them.
Let's cut the Earth in half. You can see all of its layers. Here's the inner core. It's about 40 times hotter than the inside of your oven. That's the mantle, an ocean of hot lava. Here comes the crust of the Earth, the solid surface on which our civilization lives. But if you look up, there are many layers besides the atmosphere and the ozone layer. Scientists recently discovered a strange bubble here, which protects our planet from radiation. And nope, it's not the Earth's magnetic field. This bubble is made of radio waves. Our planet grows like a Christmas tree in the radio spectrum. But we're interested in low-frequency waves, the ones that let us keep in touch with submarines. So, radio waves are like light waves, or regular ocean waves. Look at this one. The distance between the two peaks is the wavelength, and the number of these waves over a period of time is the frequency. For example, there are 10 waves in this interval of 1 second. So, can you guess the frequency of this wave? Yep, it's 10 Hertz. Cell phones use waves with a frequency of 300 to 3000 megahertz. So, add 6 more zeros to that number. But waves of that frequency don't penetrate barriers well. Think of how you lose your cell phone connection when you're driving through a tunnel. That's because there is metal inside. It's a conductive material that weakens the radio waves a lot. Salt water is also a kind of conductor. So, if the submarine is deep enough, the thick layer of water weakens the signal, and we lose communication. To maintain it, we send fewer waves but make them longer. In the same amount of time, the frequency of the short waves will be much higher than the frequency of the long waves. That's why they're called very low frequency waves. But, as it turns out, these waves travel all over the Earth and even into space. This is where things get interesting. The waves collide with particles of radiation from the Sun. We think of the Sun as a friendly giant giving us light and heat, but it actually emits a lot of harmful radiation. Each flare, or the electrical discharge of material on our home star, causes an even greater burst of radiation. These particles fly to our planet, just as radio waves do. They travel 93 million miles from the Sun to Earth in 8 minutes and crash into our bubble, which acts as a shield. Basically, radiation particles from the Sun accumulate in the radiation belts around the Earth. Our planet's magnetic field traps them, and a recently discovered bubble of very low-frequency waves lies right below this radiation belt. It helps us repel some of the harmful emissions. Analysis of old studies confirmed that the radiation belts used to be much lower and closer to Earth. But when our civilization began to use radio actively, our waves raised that belt higher. No one expected such an effect from simple radio waves, but it'll give us a way to protect astronauts in the future. When you're on Earth, its magnetic field keeps you safe from radiation. You can physically see it when charged solar wind particles make the air particles at the poles of our planet glow. This is an aurora. Next time you admire this beauty, know that it's actually the Earth saving you from some extremely harmful rays. But if you're outside the Earth's magnetic field, somewhere in space, I have bad news for you. Nothing protects you there. This is a big problem for astronauts, who spend months on the International Space Station. Perhaps scientists will learn to create protective bubbles of very low frequency waves around space stations and spacecraft. The same is true for other planets. We're probably going to colonize Mars. There is no magnetic field there, and nothing can protect you from radiation. But if you create an artificial bubble there, you can reduce the harmful radiation. Another invisible bubble protecting us is the atmosphere. It's like a layer cake or an onion. Each level of the atmosphere has its own properties. The lowest layer that we live in is the troposphere. This layer contains 80% of the weight of all the air on the planet. It's also the main place where water vapor lives. And this is where the machine called weather works. The sun sends rays of energy to the Earth. Our planet's surface reflects them and heats the air in the troposphere. This makes it move and change places with the cold air, so all the wind, cyclones, storms, and tornadoes only happen in the troposphere, up to about 7.5 miles high. That's why commercial planes fly at an altitude of around 6 miles. The wind or other bad weather conditions hardly affect this area, and the air here is not as dense as it is down on Earth. Flying 1 mile above sea level is like moving through a biscuit. It's hard, but at a 6-mile altitude, flying feels like moving through light whipped cream. The plane almost feels no resistance, so it's a win-win. They save fuel and keep the passengers safe. A couple of significant downsides are that it's very cold and you can't breathe there. It's cold because there are very few air molecules to absorb heat from the ground and transfer it to each other. You wouldn't be able to breathe here for the same reason. That's why planes are equipped with oxygen masks, just in case. Let's go a little here. This is the stratosphere. There's even fewer air molecules up here, and that's where the weather probes fly. They're the kind of small balloons with computers people use to predict the weather. This part of the atmosphere also contains the well-known ozone layer. This is our shield against harmful ultraviolet radiation. Ozone is almost the same as oxygen, except it has 3 atoms in it. When harmful ultraviolet rays enter our atmosphere, they crash into the O3 molecule. The ray breaks the molecule into O2 and another oxygen atom. The ray itself is converted into heat, but the ozone regenerates quickly. A single oxygen atom joins the O2, and the ozone molecule is ready to protect us again. It's the invisible shield that protects us from radiation. It gave birth to all life on Earth. As our civilization developed, we started to emit freon gas into the atmosphere. We used to fill our old refrigerators with it. A single chlorine atom would detach from a freon molecule when in the air, and then it would bind a single oxygen atom. Now, the ozone can't regenerate like it used to. Fortunately, we banned the use of such harmful gases, and the ozone layer began to regenerate. Scientists expect it to fully recover in the middle of the 21st century. The stratosphere ends at about 31 miles. The next layer is the mesosphere, the coldest of them all. On average, it's about -140 degrees Fahrenheit. That's 5 times colder than your freezer. This is the layer of the atmosphere where incoming meteors start to ignite because of friction in the air. Then they will eventually burn up completely. The air here is too thin for airplanes or balloons to fly, but it's still too dense for satellites. So, this layer of the atmosphere is not well studied. The next layer extends from 55 miles above sea level to about 500. That's a little more than the distance between Las Vegas and San Francisco. Kármán line is situated in this layer of the atmosphere. This is the boundary between our planet and space. The thermosphere is where all our spacecraft and satellites fly. It's also home to the International Space Station. The temperature rises extremely. The air here is about 10 times hotter than your oven can produce. It's all due to solar activity. But you would never be able to feel this heat. The air molecules that carry the heat here are so small that you would literally float between them. Imagine a giant pool with only 3 drops of water. That's the thermosphere. And the highest layer of our atmosphere is the exosphere. This is the widest layer of our air bubble. Scientists believe its boundaries are about halfway to the moon at 120,000 miles. This is the point where the pressure of solar radiation begins to exceed the Earth's gravity. It's still part of our atmosphere. This means that astronauts who went on various space missions and have been on the ISS have actually never left the Earth's atmosphere.
The James Webb Space Telescope
An astounding piece of equipment built to outperform the Hubble Space Telescope has made a terrifying and amazing discovery that might completely change our perception of the universe. It has successfully detected a faint glow coming from a staggering 7 trillion miles away. Can this glow be shining city lights coming from some mysterious extraterrestrial world galaxies away from us? Well, let's start from the beginning. A few years ago, NASA's infrared Spitzer Space Telescope helped us spot a family of 7 rocky exoplanets orbiting the same star. This star is known as TRAPPIST-1, and recently, our new infrared powerhouse, the James Webb Telescope, has measured the temperature of one of those distant worlds. It was a planet called TRAPPIST-1b. Unfortunately, it turned out that this Earth-like planet was totally uninhabitable. Astronomers took James Webb's mid-infrared camera, called MIRI, and looked at the planet's thermal emissions. We can picture the whole process as scientists using heat-sensing Terminator vision. The results were quite disappointing. TRAPPIST-1b turned out to be scorching. Its average temperature was around 450 degrees F. That's as hot as in an oven. Plus, the planet most likely doesn't have any atmosphere. At the same time, this discovery was another record-breaking first for the telescope, which had already produced some newsworthy results by that time. It was the first time researchers detected any form of light emitted by a small and relatively cool exoplanet similar to the rocky planets in our own solar system. No previous telescope had enough sensitivity to measure such dim, mid-infrared light. When 7 TRAPPIST-1 exoplanets were first discovered, the astronomical community was ecstatic. That's because all those faraway worlds were about the size of our home planet and located in their star's habitable zone. It's the region that is just the right distance away from a star for liquid water to exist on a planet's surface. Thus, the planetary system became the best place to look for rocky planets with an atmosphere. But don't get too excited yet. These planets aren't likely to become new worlds for humans to explore, mostly because the TRAPPIST-1 planets are totally out of our reach at the moment. They're just too far away, at a whopping 235 trillion miles away. Their star is also much smaller and redder than our Sun. It's classified as an M-dwarf star. In our home Milky Way galaxy, there are twice as many of such stars as there are stars like the Sun, and they're also twice as likely to have rocky planets orbiting them. It's probably not surprising that astronomers are very interested in such stars. They're the main targets for seeking potentially habitable planets, and it's also way easier and more convenient to observe rocky planets around such smaller stars. But there's a catch. M-dwarfs are more active than our Sun. They frequently flare and spew high-energy rays which are likely to be extremely damaging to planets' atmospheres and any forms of extraterrestrial life. When researchers examined TRAPPIST-1b before, their observations weren't sensitive enough to determine whether this world had an atmosphere, or if it was just a barren rock. But now, we know. The planet is tidally locked to its star, which means that one of its sides always faces the star, while the other is stuck in perpetual darkness. The latest simulations suggest that if this planet had an atmosphere, its temperatures would be much lower since the air would redistribute the heat around both sides of the planet. Unfortunately, the James Webb Telescope recorded much hotter temperatures than needed for such a favorable scenario. It indicates the absence of an atmosphere and knocks the planet off our list of possibly habitable worlds. But the main excitement here isn't actually the features of TRAPPIST-1b. The main takeaway is that James Webb is capable of making such kinds of measurements. It'll help us explore the atmospheres and temperatures of many other distant worlds.
Have you ever wondered how the world will go down in flames? Will it be due to zombies, extraterrestrial civilizations, or AI taking over? Nah, turns out it might actually be mosquitoes and scientists causing the chaos. It's funny how things created by nature aren't as threatening as the stuff that doesn't exist naturally. And you know what's on that list? Editing the DNA genome. Experiments with the genetic structure of living organisms can produce completely new species, and no one knows how nature will react to them. Let's look at an example of gene drive. So it all started with malaria mosquitoes. To somehow stop the growth of their population and prevent the spread of malaria, scientists created a gene that magically made mosquitoes only have male offspring.
Several insects with this gene transmitted it to others during the mating season and thus spread infertility. Scientists were able to stop malaria and destroy almost the entire mosquito population. But imagine if something went wrong in the mosquito genome and their population began to increase exponentially. Malaria could spread across all continents and create huge problems for all of us. Now, let's move from the little mosquito problem to a planetary disaster that can be caused by the desire for knowledge, which is deeply embedded in our nature. British cosmologist Martin Rees once said that we lived in the 1st century when human beings could determine the planet's future. It seems that it's so easy not to destroy yourself, but our nature is quite complicated. In pursuit of solving the mysteries of the universe, we have built a giant machine that, according to some people, may destroy our planet. And this device is the Large Hadron Collider. The main task of this giant machine is to accelerate particles and make them collide with one another. Scientists expect that the collider will help better understand the structure of our universe. In simple words, this is a miniature simulator of the universe. Using it may also shed light on the mystery of dark matter. During operation, the machine compresses atoms and makes them crash into one another at great speed. Perhaps this is how our universe appeared. Some people fear that a small black hole may form because of this collision. A tiny particle with a huge weight will pull all objects inside itself. Its mass will grow, but its size won't change much. As a result, it will compress the entire Earth and turn it into a ball measuring a little more than 300 feet across. At the same time, our planet will still have the same weight. A powerful gravitational pull on such a small area of matter can form a black hole that might later swallow up our entire solar system. There are also theories that the Hadron Collider could open a portal to a parallel universe with creepy monsters that would enter our world. But of course, such theories have little to do with science. Scientists have already launched the collider several times, and as you can see, nothing terrible has happened. But there is a small nuance. With each launch, scientists increase the speed of particles. Who knows what will happen when they accelerate them too much? According to Martin Rees, the probability that Earth will become a black hole is very, very small. Particles with a much larger energy charge fly in space faster than in the Hadron Collider, and nothing catastrophic happens. Okay, now let's go back to our genomic games to see what else can happen if we continue experimenting with nature. The main problem might be an imbalance in ecosystems. In the 19th century, sailors accidentally brought mice to Gough Island in the South Atlantic Ocean. Rodents had no dangerous enemies there, so their population began to grow. Mice began to displace dozens of birds from their home. The rodents attacked the chicks and reduced the population of entire species. Trying to save the birds, scientists decided to get rid of the mice, but these little creatures still managed to survive. As a result, the balance of the whole ecosystem was disrupted. Using gene drive to get rid of one species can lead to uncontrolled population growth of another. Imagine that malaria mosquitoes controlled the population of some flies. And what would happen if these flies lost their main natural enemy? The population of these flies would start destroying other species, and it would begin a chain of destructive events. All this suggests that playing with things that don't exist in nature is very dangerous. We worry a lot about how artificial intelligence can take over the world and eliminate us. Still, at the same time, we don't pay attention to our actions. Genome editing can lead to positive consequences, such as the appearance of healthier people, and destructive ones, like the creation of artificial bacteria that can cause serious health problems. In general, destroying other species is a trait inherent in humans. Because of our actions, many animals have disappeared from the face of the earth. Moreover, we even destroy each other. Such aggressive behavior is our nature. And artificial intelligence doesn't have anthropomorphic properties. Its logic may be completely different from ours, and instead of destroying people, it might strive to save them. And we have something to save us from. Remember the giant asteroid that erased more than half of the living creatures on Earth? The fall of the space rock caused a massive blast wave, a tsunami, earthquakes, and dust clouds that covered the sun. Dinosaurs and other animals couldn't survive in such conditions. But what if something similar happens these days? Fortunately, we're better prepared than dinosaurs. Firstly, we have the technology to track giant meteorites and calculate their trajectory. And artificial intelligence can also help us with this. Secondly, we can destroy an asteroid before it reaches us. Several powerful rockets will quickly deal with any space rock and turn it into cosmic dust. Moreover, we will know in advance about its approach. But suppose that a huge stone the size of dozens of Everests will fly towards us. In that case, humanity should hurry with Mars colonization. But don't worry. Observing the sky shows that large asteroids capable of causing severe damage to our planet are moving in a different direction. The most giant known asteroid that could collide with Earth might do so in 2088. The probability that it will fall on our planet is 1 in 50,000, so you shouldn't have to worry about threats from outer space. What lies in the bowels of our planet is much more dangerous. Millions of tons of magma and hot gases can burst to the surface through destructive volcanic eruptions. More than 70,000 years ago, a large-scale eruption threw a tremendous amount of ash into the air, which then floated in the atmosphere in the form of a giant gray cloud for a long time. As a result, Earth's surface cooled down by several degrees, which led to one of the most massive extinctions in the history of our planet. Some eruptions happen not only inside volcanoes. There's such a thing as flood basalt. A colossal magma bubble accumulates under a vast area and begins to seep through faults in different parts. Magma slowly goes out there for many years and destroys all living things around. And the worst thing about this situation is that we can't do anything about it. Humanity has learned to track meteorites in space, but we're still not good at predicting a volcano's behavior. Even if we find out that some giant rock will wake up in the next 6 months, there's nothing we can do about that. We won't be able to prevent an eruption. All we can do is evacuate people from dangerous territory. We have no protection against earthquakes, and even more so, we can't stop the emission of ash into the atmosphere. It's possible that artificial intelligence will help us with this in the future, but right now, we're powerless. As you can see, there are several options for the end of the world for humanity, and they're all slightly different from those imposed by pop culture and the media. In the end, is it right to look for threats from space or artificial intelligence?
So imagine being one of the first people sent to explore Mars. As you're approaching the red planet, something strange and creepy draws your attention. There, yes, right there. Doesn't it look like a mammoth bear's head? What or who could possibly create a bear's snout in the middle of a crater? Unfortunately, or should I say luckily, there's nothing mysterious about the bear's head. It's just a facial pareidolia. That's a tendency to see facial features in everyday things. But speaking about the finding on Mars, should we rename the phenomenon into pareidolia? You could see that coming, couldn't you? Alright, check it out. You see a V-shaped hill that looks like a nose. Then there are 2 craters that look like eyes. And then there's a circular fracture pattern, the head, that surrounds the nose and the eyes. Experts think that the face could be created when a deposit was settling over a buried impact crater, and the nose might be a mud or volcanic vent with solidified lava or mud flows around it. Anyway, the crater does look like a bear's face, I'll give you that. But thanks to HiRISE, the Mars Reconnaissance Orbiter's high-resolution imaging science experiment camera, another of NASA's amazing acronyms, we've seen many other crazy craters on the red planet, like smiley faces, a bird, or an elephant. First, let's have a look at the famous face of Mars. These images were first taken by the Viking orbiter in 1976. At that time, the resolution was obviously quite poor, plus the lighting was slanted, which produced the result that shocked people in the 1970s, a face carved of rock staring back at Earth. Did it mean there was another civilization on Mars that had created this monument? Nah. Look at the photo of the same spot taken by the current Mars Reconnaissance Orbiter. The resolution is much, much better, and the face has miraculously turned into an ordinary hill. Or look at this teeny Bigfoot, whose image was captured in 2008. I say teeny because this creature is just a few inches tall, and when the photo was taken, Bigfoot was only several yards away from the camera. And here, one curious soul zoomed in on a small rock and spotted something that resembled a gorilla. That's how some people started to believe there were apes on Mars. Yeah, really. Let me show you some more examples of imaginary creatures and faces on the red planet. Most of them come from a series of images taken by the Themis camera. Currently, it's on board the Mars Odyssey spacecraft, which only needs 2 hours to orbit the red planet, carrying some important scientific instruments. Let me introduce my Happy Martian to you. This 2-mile-wide crater was photographed in 2008. The next crater chain looks like a wasp with its wispy wings of impact debris. The whole feature was probably created by a meteorite that fell at a very low angle and broke into pieces right before the impact. Now, do you see a woolly mammoth or an elephant here? Lava flows in one region on Mars left this image on its reddish soil. The region itself, called Elysium Planitia, is famous for the planet's youngest lava flows. For example, the one that looks like a mammoth most likely formed in the past 100 million years. Just yesterday. Now let's talk about love, or rather its symbol, the heart. Do you like these two hearts on the surface of the red planet? This one is actually a mesa top outlined by frost, and this heart shape is an impact crater. The hit tore away dark surface material and exposed lighter soil underneath. Then some of the material probably flew downslope, creating the heart. And this dust-covered hummingbird, can you see its long beak and head? Scientists aren't sure how this shape was formed, but they think erosion and wind played a part in its creation. These dark sand dune deposits look like a howling wolf. And here, can you see a series of interlocking gears? This image looks like the letter T, right? The right angle fracture was created by the tectonic stretching of the Martian crust. Do you think we might find other letters of the alphabet on Mars too? Why not? And now, how about another bizarre thing astronomers noticed on the surface of Mars? Is that a door to someone's house? It was NASA's Curiosity rover that sent this image to Earth. It became viral because this formation over here, see, looks like a door. Unfortunately, scientists, due to their rational minds, were quick to disappoint us. They claimed that it was just a natural part of the Martian landscape. There were several clues that made them think it wasn't a real door. For example, the opening is tiny, a mere 3 feet high. They're sure that what looks like a door is actually an opening in a rock created by natural forces, like winds and erosion. If you look at the rock closely, you may notice strata. Those are layers of silt that stand out because they're harder than the surrounding material. These strata dip here on the left and a bit higher on the right. They likely appeared around 4 billion years ago in a river or a wind-blown dune. Since the strata became visible, powerful Martian winds have eroded them even more. And look at this. See those cracks? That's how rocks weather on the red planet. This small cave probably formed when several fractures crossed the strata. A pretty large boulder might have fallen out under its own weight, and this created the door-shaped opening. This theory is quite plausible, because even though the gravity on Mars isn't as strong as on Earth, it's still strong enough to do it. Besides, see that rock to the right of the opening? It has a suspiciously smooth vertical edge. It must be the culprit. It probably fell out not so long ago. But it's not only the red planet that can boast of having unusual formations. Let's take this comet, for example. This image was taken by the European spacecraft Rosetta in 2014. Can you see a face on its right-hand side? Or the moon. Here's its famous rabbit. It sits upside down with its ears pointing downward. Some people see a man on the moon. It can either be his face or the entire body. If someone sees the whole human figure, it usually looks like it's carrying sticks. Sometimes it's a toad. To spot it, look at the top left-hand side of our moon. The toad is facing upward, see? Now look at this spinning neutron star. Such a star is a collapsed core of a supergiant star with a total mass of 10 to 25 solar masses. Except for black holes and some hypothetical objects, like quark stars or white holes, neutron stars are the densest and smallest known stellar objects. Anyway, back to this particular star. As you can see, this space object, located 17,000 light-years away from Earth, is surrounded by a cloud of energetic particles. And this image, taken by NASA's Chandra X-ray Observatory, appeared in 2009 and became viral in no time. All because many people spotted a hand-like structure among all that space stuff. NASA explained that the star was spinning incredibly fast, spewing energy into the space surrounding it. This created intriguing and complex structures, like the large cosmic hand so many people see. Now look at the Horsehead Nebula in the constellation Orion. This is a freezing cold and dark cloud of dust and gas that was first noted in 1888. This dark shadowing is created by dust, and at the base of the nebula there are many bright spots. Those are young stars at the stage of formation. Pay attention to this extremely bright star in the top left side of the Horsehead. Its radiation is so powerful that the star is starting to erode the cloud around itself. It means that in millions of years, the nebula might not resemble the head of a horse anymore. Well, I won't be around then. The European Southern Observatory Very Large Telescope has captured an image in which we can see the collision of 3 different galaxies. We can even observe the effect they have on each other. But the coolest thing is that while colliding, they created a recognizable shape. Because doesn't it look like a giant space hummingbird?
NASA made this cool rover called Curiosity and sent it to Mars to see what else we can find out about the red planet, the one that will possibly become our next home. Curiosity has been exploring the surface of Mars, taking measurements and gathering data about the planet for more than 10 years. And good old Curiosity stumbled upon some interesting wave-rippled rocks in the region of the Martian surface that was kind of expected to be drier. Scientists believe this area was actually a lake bed. It might be the bottom of a dried-up lake and all that sediment and other things that have accumulated there. All this can give us some important clues about the history of the lake. For instance, the types of organisms that might have lived there, how deep the lake was, how long it was there, and similar stuff. These wave-rippled patterns tell us that these rocks may have formed when strong Martian winds were moving the water in this big ancient lake. You know that specific sound you can hear when you're holding a seashell to your ear? You actually hear it because of the way the air gets trapped inside the shell and moves against its walls. The air cannot escape, so it vibrates at frequencies that depend on the size of the shell. In other words, you have a feeling you hear the sound of waves hitting a shore. That's Mars in my imagination now, a spot where you can still hear the long-lost sound of waves crashing against the shores of mysterious gigantic lakes. During its mission, Curiosity also came across a metallic object which turned out to be a meteorite. This unusual rock that came from space is made of nickel and iron. Its name is Cacao, and it's about the size of a small car, 6.5 feet long, and weighs over a ton. This is an important discovery because we don't often find metallic objects on the Martian surface. Most of the rocks there are made of basalt or some other volcanic materials, so that chunk of metal could tell us more about the history of Mars and how it formed. Plus, it definitely stands out. The surface of Mars is red from oxides, while Cacao is metallic-looking and dark gray. It's rounded and smooth too, which means it once passed through Mars's atmosphere. There have been other robots exploring Mars too. For instance, NASA's Mars Reconnaissance Orbiter, MRO, stumbled upon circular sand dunes. Sand dunes are usually very common on the red planet. They come in many different shapes and sizes, but circular ones like these are really rare. They consist of dark sand with light-colored material surrounding them. And the cool thing is that these dunes are arranged in a specific pattern, similar to the spokes of a wheel. It could be because of the way the winds blow. But back to our buddy, Curiosity. It's been exploring many other interesting things, like oxygen levels in the Martian atmosphere. The levels change depending on the season. There's more oxygen in the spring and summer. It's still not clear why, though, and of course, even that is not enough for us to really breathe there. The concentration of oxygen on Mars is 0.1%, which is about 100 times less than the concentration in Earth's atmosphere. The atmosphere of Mars is mostly made up of carbon dioxide, with traces of other gases. Curiosity was so good that it also decided to analyze the age of rocks it found. It seems they're much older than we previously thought. Some of them date back more than 3 billion years. Curiosity found organic molecules in soil samples too. These molecules are basically building blocks of life. Now, this doesn't prove there's indeed life on Mars. It's just one of the things that suggests there might have been some form of life a long time ago. Curiosity discovered potential evidence that there might be a large reservoir of liquid water beneath the south polar ice cap, probably very salty and full of different minerals. This high salinity is the reason why this water could remain liquid at temperatures well below freezing. It would be cool to have some sort of subsurface ocean to take a dip in, especially when these crazy Martian winds are raging on the surface. And it would be great to have something that would protect us from those insane radiation levels on the red planet. There are some pretty toxic chemicals and salts in the Martian soil, which can be really bad for humans. Astronauts could potentially end up being exposed to these toxic chemicals, either through direct contact with the soil or by inhaling dust that contains these salts. Also, these substances could be a problem for growing crops. This is a really big discovery for long-term missions to Mars, because astronauts would need to be able to grow their own food so they can survive while there. Another thing that favors the idea of potential life on Mars is discovering methane there. Methane is a very important finding because usually living organisms produce this gas. So, where did it come from if not from them? In reality, there are a few possible explanations for that. One is the geological activity of underground reservoirs. Another idea is that meteorites brought methane to the red planet. What's interesting is that levels of methane are higher in particular areas. So, yeah, I don't know about you, but I'll stick to the theory that it comes from living organisms. Now, it's possible that volcanoes on Mars are still active. We know there are many extinct volcanoes on the red planet, but we've never found enough evidence to prove that some of them are still alive. Scientists studied volcanic deposits and found out that some volcanoes could have erupted maybe 50,000 years ago. Before that, everyone thought the last eruption happened 3 to 4 billion years ago. If you could compress the geological history of Mars into just one day, this would be like having an eruption a second ago. So, you never know. There might still be magma bubbling in secret under the Martian surface. All the future generations that might end up building their life there could really have some fun. Mars turned into a cold and barren place that can't really support life over time. And one of the main reasons for that was losing its atmosphere. The red planet used to have a much thicker atmosphere, similar to Earth's. One major reason for that is its relatively weak magnetic field. Earth's magnetic field helps protect our atmosphere from the solar wind, a stream of charged particles that comes from the sun. Without this protection, Mars had nothing to help it confront this insanely strong force that eventually took away most of its atmosphere. Another factor that played a big role in the loss of Mars's atmosphere is its relatively low gravity. Because Mars has weaker gravity than Earth, it's easier for gas molecules to escape into space. So Mars probably used to be more similar to our home planet. But with its current thin atmosphere, it can't keep any heat, which makes it very cold and very complicated for us to explore. But maybe it's better for us that we didn't visit the red planet back in its old times. There's this story about an ancient megaflood that might have happened there. So yes, the red planet probably used to be a wetter and more hospitable place than it is today, with beautiful flowing rivers and amazing lakes, ponds, and other bodies of water. And some research showed evidence of large channels carved into the planet's surface. These channels are way bigger than any we previously found on the planet. They suggest this megaflood happened billions of years ago. Perhaps it happened as a result of different factors, like volcanic activity, melting ice, and the release of carbon dioxide from the planet's crust. The flood may have created some temporary pools of water, too. Hopefully, it will mean more interesting clues for finding traces of microbial life. How about that?
Of all the creatures on our home planet, this could be the only animal that could survive harsh conditions on Mars. The tardigrade. These fellas have another name because of their unusual looks: water bears or moss piglets. They live literally everywhere across the globe, from coastal dunes to mountains, from the lush Amazon rainforests to the barren landscapes of Antarctica. Some live on land, but tardigrades are creatures that need water around their bodies to enable gas exchange and generally stay hydrated. That's why they prefer soil, moss, or leaves covered with a layer of water. And since they're aquatic creatures, they usually choose freshwater bodies like lakes, rivers, and ponds. You haven't come across these cool animals before because they're only 0.02 inches long. You can barely perceive them with the unaided eye. But since they're virtually immortal, we can assume they've developed some amazing survival tactics. If we loaded them in a tiny spaceship and sent them to Mars, they'd be a little shocked at first, especially because of the temperature. Sure, they can live through a wide range, even going below minus 458 degrees Fahrenheit and up to 302 degrees Fahrenheit. And Mars might seem like a very hot planet when you see it in pictures, but the temperatures there are actually low, way lower than on Earth. I mean, it's farther from the sun and has a thin atmosphere, so temperatures there can drop to minus 200 degrees Fahrenheit or go up to 70 degrees Fahrenheit. On Earth, the lowest temperature was recorded in Antarctica. It was minus 128.6 degrees Fahrenheit, while the highest occurred in California, 134 degrees Fahrenheit. Tardigrades are also pretty resilient when it comes to strong pressure. They can take one that's 6 times bigger than the pressure at the bottom of the ocean. Now, for every 33 feet you go down below the surface, the pressure doubles. So, at a depth of 2.4 miles, the pressure is 380 times greater than at the surface. And in the very deepest parts of the ocean, it can be 1,100 times greater. The pressure on the red planet is about 6 times stronger than in the ocean depths. So I guess it's a little bit too much. It would be hard for these little creatures to adjust to such conditions. They would have to evolve through the next few generations to become even more resilient so that they could enjoy their time on Mars more. The food could be one of their main problems though. Some tardigrades mostly eat plants like moss, algae, or some flowering ones, and they like them served with a portion of bacteria. Others are carnivores that eat smaller tardigrades or other microscopic organisms. Well, they'd find nothing like this on Mars. So I guess we'd have to fill their tiny spaceships with lots of stashes of food they would be able to pull inside their tubular mouths. Now we're getting to the really tricky part: water. The red planet is a dry and dusty desert today. But come on, look at all those riverbanks and dried up deltas. Water must have flowed on its surface a long time ago. It's hard to understand where it all went, but it's highly possible most of the ancient water ended up trapped within minerals on the planet's crust. Some older research suggested that most of this water had escaped into space when the sun's radiation had ruined the atmosphere of Mars. But a new study has shown that only a little bit of water escaped, while most of it is still there, hidden and waiting for us to discover it. Also, a few years ago, researchers found signs of hydrated minerals on the slopes of the red planet, where they saw mysterious darkish streaks that seemed to flow. It mostly happens during warm seasons, since they fade when it gets cooler. These downhill flows could be evidence of real liquid water on Mars. Scientists have discovered some minerals that confirm this idea too. These minerals can lower the freezing point of water like salt does on icy roads. That's why scientists think there might be a shallow underground flow of briny water that causes these streaks. Tardigrades probably have excellent instincts, considering they can survive even in the toughest conditions. so they'd probably find water on Mars way before us. But even if they didn't do it right away, they would still have their tactics to stay alive for a while. If this creature loses 99% of its water content, it can survive by pausing most of its vital functions. It can remain in such a state for a couple of years. Tardigrades can absorb extremely strong impacts that would easily crush other animals, including us. They can withstand radiation levels so high that they could destroy a human. And even if we do send tardigrades to Mars one day, that won't be their first trip to space. In 2019, a spacecraft went to the moon, carrying thousands of tardigrades, the first lunar library, human DNA samples, and a DVD-sized archive that contained 30 million pages of information. The idea was to create archives of all the knowledge the human race had collected. But seconds before the spacecraft had to land, the mission control lost contact with it, and it crashed into the surface of the moon. The team was wondering what was going to happen with the spacecraft's cargo. After lots of discussion and analysis, they assumed that the library had survived, and even crazier, perhaps tardigrades had too. They were in this dehydrated kind of dormant state, so they shriveled up into tiny balls. They lowered their metabolism and expelled most of the water from their bodies, waiting for a better environment where they could be their best selves once again. These creatures can stay like this for decades and survive extremely harsh conditions. And this wasn't the first organized tour to space for tardigrades. In 2007, a team of scientists sent a group of these tiny water bears to orbit our home planet on the outside of a rocket for 10 days. They did pretty well, considering that when the rocket got back to Earth, 68% of these creatures were alive. Scientists don't put all their hopes only on these water bears. They keep testing if there are some other life forms that could survive on the red planet. They did an experiment called Biomechs on the International Space Station. They took tiny organisms such as algae, bacteria, and other similar creatures and kept exposing them to really tough conditions in space for 18 months. This means things like huge changes in temperature, extreme radiation, and vacuum. The amazing part is that many of these tiny life forms survived these harsh conditions and came back to Earth as true space heroes. So they could probably deal with the hardships of living on Mars. Scientists studied archaea as well. Those are tiny, ancient microorganisms that have existed in salty seawater on our planet for more than 3.5 billion years. Some of their relatives from the Arctic also survived in space-like conditions. But life on Mars doesn't have to be a whole new thing. Billions of years ago, the red planet might have been a bit like Earth. It most likely had water, and that's one of the key ingredients for life. Scientists believe tiny organisms called methanogens might have thrived there. They were hiding beneath the surface to stay safe from harsh radiation. These organisms could have breathed in hydrogen and carbon dioxide, exhaling methane gas. But as they gobbled up hydrogen, which was a powerful greenhouse gas back then, they might have cooled the planet too much. So it's possible these ancient microbes are still somewhere there, trapped in ice deep below the surface. They could be in a sort of deep sleep, waiting for better conditions to wake up, or some new cool friends from Earth.
There are tons of weird things on Mars. Spoons, noodles, doors, even faces. Are they all really just rocks? Besides, it's not the only planet in our solar system full of mysterious things. Let's check them out. Recently, we found a strange thing on Mars that looks like a smooth, spoon-like object. It grabbed everyone's attention after NASA's Curiosity rover spotted it. The rock, with a handle and rounded tip, looks like it's floating in the rover's photo. People on the internet are puzzled about what it might be. Some are joking that it's a Martian's bowling pin, or even a shoehorn left by extraterrestrial creatures. But Andrew Good from NASA says it's not that exciting. Turns out it's just a rock shaped by the wind over a long time. These kinds of rocks with odd shapes are common on Mars. They're called ventifacts. Ventifact is a rock that can get scratched, dented, or smoothed out by tiny particles carried by the wind. You'll usually find these kinds of rocks in dry places where there's not much grass or trees to block the wind, and where there's a lot of sand blowing around. Sometimes, the wind can carve ventifacts into really cool shapes, like the mushroom rocks you can see in the White Desert National Park in Egypt. These rocks look like giant mushrooms because the wind wears away the bottom part faster than the top, making them stand tall and slim. Ventifacts aren't the only cool Martian rocks. Check out this series of surreal spikes protruding from the red surface. NASA's Curiosity rover stumbled upon them while exploring the Gale crater on Mars. They quickly caught everyone's attention. Twisting structures resembling spikes looked like some extraterrestrial doors. Even the SETI Institute, an organization focused on searching for extraterrestrial life, tweeted about the image, referring to it as a cool rock. But in reality, these are just hoodoos. These tall and thin spires occur when hard rock sits atop softer rock layers. Martian spikes are likely cemented fillings of ancient fractures in sedimentary rock, with softer material eroded away over time. Again, there are many hoodoos on Earth too. They're also called fairy chimneys or tent rocks. You can find them in places like Utah's Bryce Canyon and the Colorado Plateau. NASA is excited about these weird structures because they can help us learn more about the history of the Gale crater. There was also a rock that looked like a jelly donut. We called this rock Pinnacle Island. It was spotted by NASA's cameras. However, just 4 days earlier, it was nowhere to be seen. So how did it magically disappear? In a very anticlimactic way, it was kicked up by one of Opportunity's wheels as it traversed the Martian terrain. But there's still some mystery surrounding that jelly donut. Analysis revealed that Pinnacle Island contains unusually high levels of sulfur and manganese. Both of these things are water-soluble. In other words, there might have been some water action that created these elements in the rock. So this tiny thing suddenly caused a lot of drama, and an entire lawsuit against NASA. It claimed that the agency failed to investigate a possible fungus growing on Mars. Jelly donut fungus. But not all our findings are natural. Another puzzling discovery was this thing the Perseverance rover spotted. It's something that looks like tangled spaghetti or string. Just like the donut, this mysterious object showed up in a rover camera image and then vanished from the sandy ground in several days. It turns out that it could be debris from the rover's landing system. Perseverance landed in the Jezero crater in February 2021. It had a rough landing and accidentally scattered debris around. Some of these debris pieces have been showing up in the rover's images for a while now. The string-like object is likely a piece of shredded Dacron netting, which is a type of fiber used in thermal blankets. These blankets help regulate equipment temperatures during the super hot process of landing on Mars. It probably underwent significant unraveling and shredding due to strong forces during the landing. Thermal blankets lost a bunch of stuff back then. For example, this shiny foil piece spotted in June. The rover found it on a rock. What's remarkable is how far some of the debris has traveled. The rover landed about 1.2 miles away from where it's currently exploring. It's probably because the crash threw the debris into the air, and the Martian winds carried it over such a distance. Mars is known for its strong winds, which can move lightweight objects. However, while it's fun to stumble upon them on images, there are concerns about the debris and trash on Mars. We haven't even fixed this problem on Earth, and we're already creating it on Mars. The debris we left on the red planet is already accumulating in an area called Hog Wallow Flats. Plus, the debris can accidentally contaminate the sample tubes used for collecting Martian rocks. So far, NASA isn't overly worried about this, but they're keeping a close eye on it to prevent any issues with the rovers. Now, how about not things, but animals? Curiosity caused quite a stir when it captured something that looked like a rat on Mars. Some started speculating that it could be evidence of indigenous Martian life, or even that this rodent was brought along by Curiosity. But the Mars rat, once again, turned out to be just a weird rock. It looked interesting because of the natural processes like wind erosion and mechanical abrasion. We also found some worm-looking things. Curiosity snapped a picture of a formation that looks like worms wriggling across the Martian landscape. Despite its tiny size, this formation stands out with its unique shape and rough texture. It's probably made of durable material resistant to Mars's harsh erosion. And finally, our top mysterious finding is the face on Mars. Cydonia is a region on Mars that has captured both scientific and popular interest. It's located in Mars's northern hemisphere. It lies between heavily cratered regions to the south and relatively smooth plains to the north. There's a theory that the northern plains may have once been ocean beds. Maybe Cydonia was once a coastal zone. This place is full of interesting and beautiful features that tell us a lot about the history of the Red Planet. But its most interesting feature was the Martian face. This thing gained widespread attention when it was snapped by the Viking 1 orbiter in 1976. Some believed that it was evidence of a long-lost Martian civilization. At first, NASA dismissed it as a trick of light and shadow. But after some analysis, it turned out to be, yep, another rock. We also saw a face of a bear. It was captured by the high-resolution imaging experiment camera. In an image, we can see a circular fracture pattern that looks like a bear's head, with two craters forming the eyes and a V-shaped collapse structure like the nose. The head likely formed because something heavy settled on top of an old hole in the ground. This hole was filled with either lava or mud. The nose-like feature is speculated to be a volcanic or mud vent. But why do we keep seeing these strange things on Mars? Sometimes our brains can trick us into seeing things like faces or objects in rocks and other things. But these are just illusions called pareidolia. Pareidolia is a psychological phenomenon that makes us see familiar patterns or shapes, especially faces, where none actually exist. It's because the brain encounters something it doesn't recognize or understand right away. It tries to find things that look the most like this one. So it sees random patterns, textures, or sounds as something meaningful and recognizable. That's why a chair and clothes on it seems like a super creepy human-like figure at night. It also causes you to see faces or shapes in clouds, or hear recognizable sounds and even words in random noise. It's a fascinating proof of the power of our perception, but we also should be careful with it and not let our imagination run wild.
Recently, scientists have made an astounding discovery that can change the entire course of Mars exploration. Apparently, there are oceans of liquid water on the red planet, so the future looks bright. We could use this water to support future missions and then even relocate to Mars, since we wouldn't need to worry about where to get this precious liquid, right? Well, there's one big problem. These oceans of liquid water are in Mars, so deep inside that we aren't likely to get there. At least that's what a new analysis of seismic data collected by the Mars InSight lander claims. Huge reserves of liquid water seem to be the best explanation for some seismic quirks of the red planet. So all this precious water is out of our reach. But we need to find it to solve the puzzle of the aquatic history of our blushing, dusty neighbor. And the first thing we need to do is identify where the water is and how much of it the planet is hiding.
Navigation has confirmed that the parachute has deployed and we are seeing significant deceleration.
Now, our rovers are scurrying about on the surface of the red planet, gathering all the available data on the planet's surface geology. And it's getting increasingly obvious that Mars was once covered with water. Many factors, from Martian terrains to ancient dry lake beds and deltas, suggest that there was a time when the planet was quite soppy. These days, there's still some water on and right below the surface of Mars, but it's in the form of ice and nowhere near what Mars had in the ancient past. To understand how much of it could have been on the red planet billions of years ago, we must know where all this water went. There are two spots where the water could have gone: into space or toward the interior of Mars. Then it could have been isolated as either liquid reservoirs or ice deposits. Currently, we don't have any way of measuring how much water once leaked away. But now, we finally can find out more about the gooey center of the red planet. All thanks to the Mars InSight lander. It isn't operating anymore, but from November 2018 to December 2022, it was listening to the hums and rumbles and monitoring the activity below its feet. The thing is, acoustic waves generated by seismic activity deep inside the planet can change according to the composition and density of the material these waves are moving through. And scientists can get a lot of information analyzing the behavior of seismic waves. In this case, they used a model similar to those used to map underground oil fields and aquifers on our home planet. Then, with the help of this model, they analyzed the data gathered by InSight on Mars. They discovered that the best explanation could be that there was a layer of fractured rocks whose cracks were filled with water deep under the surface of the red planet. That layer could be at a depth of 7 to 12 miles. That's why it would be extremely tricky for future missions to get to it. And still, the new discovery could help us understand the Martian water cycle. Confirming the existence of a large reservoir of liquid water can help us sneak a peek at what the climate on Mars used to be or what it could be like one day. And if once Mars had a lot of water, it could have been habitable in the ancient past and might become habitable in the future. Water is crucial for life as we know it, so underground water reservoirs on the red planet could already be habitable. Maybe, while we're talking, tiny microorganisms or even some tentacled creatures are living their lives in the comfort of their underground home. On Earth, super deep mines do host life, and the bottom of the ocean, with its immense unbelievable pressures, isn't lifeless either. So far, we haven't found any evidence of life on Mars, but for now, it sounds like this place has the potential to sustain life. InSight data has shown that there isn't likely to be a lot of water ice in the upper crust of the planet, at least in the region around the lander. But if it turns out that there is a water-rich layer deep below the surface and stretching around the entire globe of the planet, then there would be enough water to fill ancient ocean beds and even more. Now, Mars isn't the only place outside Earth where there is water or where we might one day find water. Take the good old Moon, for example. On Earth's natural satellite, water can be found all over the surface, but it's not the water you might be imagining. On the Moon, water remains mostly as ice, and it's distributed unevenly. For example, the poles of the Moon are the regions that never receive sunlight. This is the reason they're extremely cold, and it's no wonder there's a lot of ice there. The ice in these areas is often mixed with the lunar soil and hiding deep below the surface. Then there's Enceladus, the sixth largest moon of Saturn. In reality, it's not that large, just 314 miles across. In other words, this moon is small enough to fit inside Arizona. Ooh, we should try that. Well, interestingly, when the Cassini space probe first arrived at Saturn, researchers were expecting Enceladus to be a frozen ball of ice. But what they saw was plumes of icy particles and water vapor erupting from geysers on the moon's surface. It was clear that there was a massive ocean between the moon's rocky core and its icy shell. Then there's Jupiter's moon Europa. Scientists think that this world is one of the most promising places in the solar system when it comes to searching for new life forms. That's because Europa has a huge saltwater ocean as deep as 40 to 100 miles. And even though it's under a layer of ice that is likely to be 10 to 20 miles thick, it's still potentially habitable. Astronomers believe that plumes of water might erupt from cracks in the ice shell and release the contents of the moon's ocean into space. The temperature, pressure, and chemistry are very different on Europa, and astronomers aren't sure yet how the ice behaves there. That's the main reason they haven't figured out yet how deep or large the water reservoirs on Europa are and how long they need to refreeze. But out of all the places where we could find water in the universe, the most bizarre is probably open space. In 2011, two teams of astronomers discovered a cloud of water floating freely among stars. It was the largest and farthest reservoir of water ever detected. So this massive cloud of water vapor surrounds a black hole. But not just any black hole. This one's a quasar, located 12 billion light-years from Earth. The conditions around this quasar must be really special to create such an enormous amount of water. This cloud contains 140 trillion times the volume of all the water on Earth. That's enough to give every person on the planet a whole planet's worth of water 20,000 times over. Sounds wild, doesn't it? But there's something even cooler. Astronomers think this water cloud formed just 1.6 billion years after the universe began. This discovery is yet another sign that water has been around all over the universe, even in its early days. But here's the kicker. Until they found this, scientists had never detected water vapor so far back in time. Sure, there's water in our Milky Way galaxy, but most of it's frozen solid in ice. This discovery really pushes the boundaries of what we know about water in the universe.